Okay, this is my second slideshow on fertility, and let's see where we are going. As always, the first thing in anything is library tidyverse, and we also need, for this thing, we need library plotly, and then we need the data. We're using by state 320 since 321 is not available. Unfortunately, it looked like it was available, but it was not. Okay. So make a graph showing the total number of births per year. And realize that what you've got is yearly data, but it's by state. We want the total number of births for the entire country. So I'm going to give you a few minutes to do that. Please pause the video, and when you're done, restart the video. Okay, you're back. Let's take a look. So I'm going to create a ggplot object called G1. Starts with by state 320. Then we group by year. And we summarize that the total births is equal to the sum of the births. And then we do the ggplot with that data. We put year on the horizontal axis and total births on the vertical axis. Do a geom underscore point and get a gg title, total births by year. And then we do ggplotly G1. Okay. So here we go. This is the peak year. We had the most births in 2007. And then probably as a result of the Great Recession in 2008, things dropped off. And then they were recovering 2012, 2013. Well, they weren't really recovering in 2013, but they recovered in 2014, just a little bit. Not back up to anywhere near where it was, but at least a little bit better than 2013. And 2016 is a slight decline, and then we have a real decline through 2017, 2018, 2019, and 2020 was just kind of off the cliff. Okay. So total number of births has declined, and one of the original thoughts you might have that, well, if we had fewer women, then you would expect fewer births. So what I want to do is redo the previous data frame and include the total number of women, and also compute the ratio of births to women, and print the data frame so we can see all three variables. Okay, again, I want you to stop the video and do what this thing asks you to do, and then restart the video. Okay, you're back. So here are the, look at the total women column, and you can see, did they drop? No, went from 617 to 643. No, it definitely didn't drop. Okay. The births dropped quite a lot. And the reason why the births dropped is that the ratio has dropped. The ratio of births per woman. Well, this might not be anything to be alarmed about. It might be that we just have women who have aged out of their childbearing years. So we need to think about that. And the right way to think about this is through what we call the total fertility rate. It's the number of births for a woman during her lifetime. The rate data we have is the number of births per woman per year while she's in one of the 5-year age groups. A little bit of mathematical gymnastics here. How do we use the rate information, the rate information that we have, to construct the total fertility rate? do this for the state of Washington and just plot the time series using Plotly. Okay, and again, I want you to stop the video and do the work and come back and look at the way I've done it. Okay, you're back. Let's go on. So again, I started with by state 320, and then I filtered, just look at the state of Washington, and group by year. And here's the trick to turn those yearly rates, births per woman per year, into the total fertility rate. You add up all the rates and multiply by 5. Okay? And having done that, then you ungroup, and now we can take that data and ggplot it. And on the x-axis we put year, and on the y-axis we put the total fertility rate, and then do a gm_point. And you can see pretty much the same picture that we've been looking at. There's 2007, 2008. Total fertility rate slightly over 2. Well, here's something significant happens. When you get a total fertility rate below 2, your population is declining. Figure that a woman has to have during her lifetime 2 babies and a little bit more to make up for losses. One to replace herself and the other for a man to go along with her. And if we trace this thing for the state of Washington through the years, 1.8 in 2016, 1.7, and when we finished in 2020, we're down below 1.6. Wow, that's bad. Okay. So repeat the exercise for all the states. And again, use Plotly so we'll be able to identify states. And then in the aesthetic, add group equal state. And then draw a red horizontal line at 2.1, which is approximately the break-even ratio where you would have just a not growing and not shrinking population. Okay, again, I want you to stop the video, do the work, and then after you've done the work, or after you've given up, come back and look at the way I've done it. Okay, you're back. Let's continue. So G3, by state 320, this time group by state and year. And again, the same arithmetic to get the total fertility rate. And then after we've done the summarizing, we do the ungroup. And then in the ggplot, X is year, Y is rate, and group is state. Saying group equals state, notice that we didn't join points by state, but that means that you'll be able to see the name of the state in the hover when we look at the details of a point. And I drop the size of the points to 0.2, and then I put an intercept at 2.1 so we can see kind of where we are relative to break even. Here, back in, what was this? 2003, we had a very healthy growth in Utah, like 2.6 births per woman in her lifetime. And you can see the cloud kind of drifting down. And finally, when you get to 2020, every state is below the break-even. The highest is South Dakota with a 1.97, then Nebraska, Utah, and Alaska. And bringing up the rear or the bottom, you have Vermont with a total fertility rate of 1.35. Wow, that's low. Oregon, 1.38. New Hampshire, Rhode Island. A lot of states in the Northeast have very low total fertility. Okay. So I want to create a graph showing the total fertility rate for the U.S. as a whole rather than individual state. You can't use the rate data that you've got directly because you need to compute the total number of births and total numbers of women for each age group and year. That is, you have to eliminate the state level, and then you compute the TFR by adding the calculated rates and multiplying by 5. Okay, again, please stop the video, do the work. When you're done or when you've given up, go ahead and look at what I've done. Okay, you're back. Let's take a peek. Here we get what we need to calculate the rate for the entire country. We have to add up all the births for all the country, and then add up all the female populations, and then rate is births per pop, and this gives us a rate for every 5-year age group. And then we summarize the total fertility rate is the sum of the rate times 5, then ungroup, and then GG plot. Again, X is year, Y is TFR, GM underscore point, GM underscore H line to give us our red line at the break even. And you can see that the United States as a whole was actually below the break even back in 2003, 2004, 2005. Only got above the break even in 2006 and 2007, and then since then has just been sliding downhill. And when we get to 2020, we have a total fertility rate of 1.64. Okay? That's not a good omen for the future. Okay? So that's all for this particular little video lecture.